Greetings of the day. Good evening, one and all present here. A warm welcome to the fourth day of Atal FTP on the topic Advanced Recurrent Neural Network for Sequential Data. It is a great pleasure to have you all here today. Once again, a hearty welcome to all. Let's start the today's session with the guest speaker, Dr. A.S. Santi Ma'am, Associate Professor, Dr. NGP Institute of Technology in the Department of Artificial Intelligence and Data Science. Profile of the speaker. She holds her UG degree in CSE from Bharathiar University, Coimbatore, PG degree in software engineering from Ramakrishna Engineering College. She has received her Doctor of Philosophy in CSE from Anna University, Chennai. She had 22 years of teaching experience. She has guided more than 150 undergraduates and postgraduates. She has published 40 papers in reputed international journals, national conferences, other journals, and had published 2 patents. She has chaired and organized various conferences, workshops, and seminars. She is a reviewer of referred journals, conferences, and a member of professional societies like AE, IAENG, and ISRD. She has conducted STTP and workshops funded by AICTE. She was awarded as Outstanding Personality for her social responsibilities by Junior Chamber International in the year 2010, received Youth Talent Promotion Faculty Award from Rotaract Women's Club in the year 2017, received Miss Women Sarah 18 Award from Rotaract Club of Tirupur North for her excellence in academics and social responsibility during the year 2018, awarded as Seva Ratna by International Tamil University during the year 2018. She also badged an award titled Inspirational Teacher who has demonstrated excellence in education and for creating a change in society by Park Golden Jubilee Teachers Award in 2023. Welcome you for the session, ma'am.
Thank you, MC Dev, for your nice introduction. Am I audible?
Yes, ma'am.
Yes, first and foremost, I hello. Is my voice is clear?
Yes, ma'am,
Yes,
it's
ma'am.
clear.
You are audible.
My sincere thanks to all the faculty coordinators and student coordinators as well, and my hearty welcome to participants. Let's start the session. Is my screen visible to all?
Yes, ma'am.
Yes, ma'am.
Am I audible? Yes, thank you.
Ma'am.
Yes, ma'am.
Yes, ma'am.
So right now we are in the fourth day of Atal 6-day online FDP, and for about today's session, let us discuss on various concepts regarding RNN variants, which is nothing but recurrent neural networks. So before getting into RNN, let's start some small introduction about the deep learning. Okay, of course, without knowing the deep learning, it is very difficult to understand RNN. As we all know that deep learning is a subset of machine learning that uses the neural network with multiple layers to extract features and patterns from data. So before getting into the topic, let us discuss about the need for learning these kind of deep learning, machine learning, artificial intelligence nowadays. If you see the data usage or otherwise the data transfer day by day, it's getting increased drastically day by day. So there is a necessary procedure for handling these bulk of data. That's why we are wherever we are seeing, we could able to hear the name AI, deep learning, machine learning, neural networks, everything. Of course, after Corona, being in the digital era, we are rich in data, but we are very poor in information, right? Of course, information is the processed data. So through this information only, we are getting some, no, we will be able to know something about the data, and using this information only, we'll be predicting the data in future, how the data will be like that. So there is an all the emerging technologies are based on these kind of artificial intelligence, machine learning technologies, deep learning technologies. So it is a compulsory topic that each and everybody should know about these terms. This is that's all small introduction about the AI. Why we are hearing this word wherever we are going. While coming into deep learning, so it's a subset of machine learning. Machine learning is nothing but we are making the machine to act like, to think and act like a human being, right? So it's a subset of machine learning that uses neural networks with multiple layers to extract features and patterns from the data. So here features are nothing but the basic unit of the data, and the patterns are nothing but we can collect the uniformity, we can see the uniformity in the data. So through which we can get some knowledge about the data, which will be used for further prediction about the current data. It also enables the automatic feature learning, make it effective for complex tasks like image recognition, speech processing, and natural language understanding. So this is the main important application of your deep learning. If you see the structure, so it is a subset of machine learning, is the subset of artificial intelligence. It enables the machine to mimic human behavior. And machine learning in turn is a subset of AI technique, which uses statistical methods to enable machines to improvise with experience. And in turn, deep learning is again a subset of machine learning, which makes the computation of multi-layer neural network feasible. So before getting into deep learning, we'll see what about the neuron and what is it's all about. A neuron is a basic unit of information processing in a neural network. It is widely seen in our brain also. The neurons are arranged in layers to solve the problems. So how do neuron works in neural network? So they are artificial neurons that work together to solve a problem. Okay, so you are so similar to the human neurons, we are also making neurons to mimic the human behavior. Each neuron has three properties, right? So these properties are bias, weight, and the activation function. So bias is nothing but it is a constant value that is added to the weighted sum of each and every inputs to the neuron. It is a learnable parameter also that helps the network to adjust its output, okay, so as to ensure whether it fits the training data. So how does this bias work means? It helps the network, the entire network, shift the activation function towards the positive or negative side. So we'll see, in turn, we'll see what is activation point and all. This bias helps the network see more patterns. So using this bias concept, we can extract the various patterns from the network, and also it uses to learn about the network better, and also it helps the network to give more correct answer. So we can get the accurate answer using this bias concept. And the next important property of your neuron is weight. So it refers to the numerical parameter that determines the strength of the connection between the two neurons. So depending on the strength only, we could able to analyze the various properties and as well as the output of the processing. And it is essentially used to control how much influence and input from one neuron has on the output of another neuron. It also used to analyze the dependencies between each and every neuron with respect to their input and output aspects. It's a key component in how the network learns and make predictions based on the data. So this is your second characteristic of your neuron. And hello, hello, am I audible?
Yes, ma'am.
And the third characteristic, the activation function. It is a mathematical function basically, which are applied to the output of a neuron. So they are applied to the output of the neuron. It introduces the non-linearity in the model, allowing the network to learn and represent the complex patterns in the data. Without this non-linearity feature, and a neural network would behave like a linear regression model, and no matter how many layers it has. So these are all the three basic properties of neuron via weight and activation function. And these neurons, how they are connected with each other means with the help of synapses. Of course, the synapses are multiplied by their respective parameters and then added together at the summing junction. So these are all the weights, and then they are added together with the bias, and also they are fed into the activation function in order to get the desired output. And this is the structure of your neural network. So they are computational models inspired by the human brain. They consist of neurons, otherwise they are called as nodes. So these are all the nodes, otherwise neurons arranged in a layer that process information and learn from the data. So we can see the three types of layers in this diagram, namely input layer, hidden layer, and output layer. So what we can see in the input layer, and what is the responsibility of input layer is it just receives the raw data. It may be pixel of an image, or it may be words in text, anything. So that is the input layer, and the output layer is nothing but it has the responsibility of producing the final prediction or classification result. Okay, in between these two layers, input layer and output layer, we are having plenty of hidden layers through which the various processing is to be carried out. So they perform computations using neurons and various activation functions. And next we'll get into the topic how these neural networks are working. So there are mainly two phases are there. First phase is named as forward propagation. Okay, so here the data flows from input layer to the output layer through various hidden layers as we discussed. Each neuron applies a linear transformation using weights, inputs, and biases. So the transformation takes place between these three characteristics of neuron only, namely new weights, inputs, and biases. The result is passed through an activation function. So these are all the example for activation function: a ReLU, sigmoid, and tanh. So these are all the important examples which are applied frequently in all types of workings of neural network. They are used to introduce non-linearity, and also they are responsible for continuing the layer by layer to generate the final output. And the second phase is backward propagation, and then here the network minimizes the loss by adjusting the weights using gradients. So this is responsible for adjustment of weights. Okay, so these adjustment is exclusively done by the various gradients. The gradient calculator, it uses the chain rule to determine how weight changes the impact loss. Okay, how weight this it changes the impact loss. So that is purely done by the gradient calculation. And weight update. So they are otherwise called as optimizer. The example is SGD, ADAM, RMS, PROC. So they are the optimizer, and they are responsible for adjusting the weight in the opposite direction of the gradient, because they are applicable in the backward propagation. Okay, so they adjust the weight in the opposite direction of the gradient. So this is the pictorial representation of two phases: forward propagation, and here X1, X2 are the input layers, and in between they are the hidden layers, and then various predictions and the true values are fed into input as the loss function, and from that we can calculate the loss score, And optimizer, of course, the optimizer is responsible for adjusting the weight, and at last the weight is being updated during the backward propagation. And next we'll see the type of neural network. So the first type is feed-forward networks. So they are the simplest of neural networks, where the data flows from the input layer to the output layer without any cycles or loops. So you can't see any cycles or loops in case of your feed-forward. That's what they are called as feed-forward networks. In this architecture, the interconnected neurons are arranged in various layers, with each layer fully connected to the next. So no layer is left unconnected. So each and every layers are connected to each other. They are dependent to each other. And if you see the basic structure of FNN feed forward network, the information in feed forward flows in a unidirectional manner. If you see the diagram, so all the information are flowing from in a unidirectional manner, a single direction, starting at the input layer, passing through any hidden layers, and reaching the output layer. So due to its simple structure, it is suitable for many basic prediction tasks. And if you see, you've taken one example, use cases of the feed-forward network. They are suitable for straightforward classification or regression problems. So regression problems are used to identify relations between who are more variable. Okay, so they are very suitable, more suitable in case of these kind of problems, such as predicting house prices by seeing the raw materials used for the construction of the house, and also it is by analyzing the location where the house is situated. So likewise, by analyzing all these raw data, it is very useful for predicting the house prices, and also where the input features are directly mapped to the output predictions, as we are seeing in the feed-forward network.
Stand by Pilitala.
And the next type is convolutional neural networks. They are designed to process grid-like data, especially images. So for images, the convolution networks are suitable networks for analyzing various images. The layers used in CNN performs convolutions to automatically extract features from images. Okay, so feature is nothing but the basic data, okay, through which you can analyze the image, you can pre-process the image. Okay, so the basic features of images are edges, textures, and shapes. These features are then used to recognize objects, patterns, and in turn, we can classify the images with respect after recognizing the objects and the patterns. So this convolution neural network consists of three main types of layers. One is convolution layer, pooling layers, and then fully connected layers. So, what is the responsibility of convolution layer is it is responsible for detecting the local features using convolution operations. So, local features nothing but edges, textures, and the shapes. And pooling layers, it is responsible for minimizing the computational load and avoid overfitting by reducing the spatial dimensions. So, it is also responsible for analyzing the weight of the neurons, right? And then when we are coming to fully connected layers, these layers present at the end of the network, and also they integrate the features learned in the previous layers, that is, which are learned in the convolution layer and the pooling layer. And it is also used to convert these learning into final prediction. So that is the responsibility of your fully connected layer. And then a special feature of this convolution neural network, the architecture can exploit spatial hierarchies in pixel data. It captures the low-level feature like edges in earlier layers and combines them into high-level representation in deeper layers. So when we are getting into deeper, so this is used to convert the low-level feature into high-level representation. And also this feature make them effective for tasks such as face detection and medical image analysis. So we can find this major applications in analyzing the various medical image analysis, that too analyzing the images related to cancer. Okay, brain MRI brain scan images. This particular spatial feature is showing a full responsibility of detecting the various edges, features, and as well as patterns. And the next type is GANs, that is Generative Adversarial Networks. It consists of two competing networks, a generator and a discriminator. Okay, so it's a combination of two types of networks, your GAN network, which are namely generator and a discriminator. So they are trained together. The generator tries to create a realistic data, okay, and the discriminator attempts to distinguish the real data from the fake data. So this discriminator is highly responsible for identifying the fake data by thoroughly analyzing the real data. Okay, so they are interrelated to each other, discriminator and our generator, right? So when coming to our competitive setup, the generator creates the data, as say for example, images and videos from the random noise, and the discriminator checks whether the generated data is real or fake. So random noise is nothing but, so it is a collection of data, needed data and unwanted data. So from that, your discriminator checks whether the generated data is real or fake. Okay, the